So, dear students, today I'll solve some problems on Fourier series. Okay, in the last class I've discussed about the Fourier coefficients and how to find out the Fourier coefficients. I've already told you, and the formula that I can one more time I can remind you the formulas. Okay, so let me see. Okay, so what were the formulas that we have discussed in the last class? How to find out the Fourier coefficient? Let me see. Okay, so we have the Fourier series like this, f of x, which is obviously a periodic function, and a periodic function can be written in terms of sine and cosine terms. So it can be written in terms of series of sine and cosine, that is a0 by 2 plus summation n cos nx plus bn sin nx. Okay, so this is the Fourier series of the function f of x, and we have defined the period of this function f of x, the range minus pi to plus pi. So it is period of 2 pi. Okay, and the coefficients a0, an and bn can be find out by using this kinds of integration. That is a0 is equal to 1 upon pi integration minus pi to pi f of x dx, and an is equal to 1 upon pi integration minus pi to plus pi f of x cos nx dx, and bn can be written as 1 upon pi integration minus pi to plus pi f of x sin nx dx. Okay, so these are the formulas for this periodic function f of x. We have to find out this a0, an and bn. Okay, then we can express f of x in terms of sine and cosine series. So we are given a function f of x, and we have to expand this function as Fourier series like this within the interval minus pi to pi. There is a period of 2 pi. Okay, so let me solve one or two example that you can understand how we have to find out the Fourier series. Okay, so here is the first problem. So let me solve this problem first. A periodic function f of x with period 2 pi is defined as f of x is equal to x square, and it is from minus pi to plus pi. Okay, expand f of x in Fourier series and hence show that summation 1 upon n square is equal to pi square upon 6. So let me first find out the Fourier series of this function. We are given that f of x is equal to x square. So what we have to find out first, a0, an and bn. Okay, so what is a0? So a0 is nothing but 1 upon pi integration minus pi to pi, okay, x square dx, because f of x dx, and here f of x is x square. So what will be the integration of this integration? So this is x square is nothing but even function, and as minus pi to pi x square dx, so we can write from the definition of property of definite integration, we can write this as like 1 upon pi, and this integration can be written as 2 integration 0 to pi x square dx. Okay, and this is 0 to pi x square dx is x cube by 3, so it will be pi cube by 3, so it will be just 2 by pi into pi cube by 3. Okay, so it will be 2 by 3 pi square. Okay, so the value of a0 is 2 by 3 into pi square. So this is a0. Now what is an? So an will be 1 upon pi integration minus pi to plus pi f of x cos nx dx. So here f of x is x square, so x square into cos nx dx, x square into cos nx dx. Okay, and you can see here this is also even function, because x square is even function and cos nx is also even function. So even function into even function is always even function. So this is also even function. So you can use again the property that this integration can be written as like this. So it will be just 1 upon pi into integration 2 0 to pi x square cos nx dx. Now just we have to integrate this as uv. Okay, so this is integration by parts. Let me find out integration. Just integration 0 to pi x square cos nx dx. So this is the first function and this is the second function. So first function unchanged, So this is x square, and integration of second function, and integration of cos nx is sin nx. Okay, so it will be sin nx by n, sin nx by n. Okay, then we have to integrate this, differentiate this function, so it will be minus 2x, and integration of this function is now minus cos nx upon n square. Again we have to differentiate this function. The differentiation of this function is just 2, so it will be plus, the sign will be alternate, plus minus plus minus. Okay, so it will be just minus 2, sorry, plus 2, plus 2, and now again we have to integrate this function, so it will be now minus sin nx upon n cube. Okay, so this is the integration, and we have to put the limit from 0 to pi, so it will be just like this. So this is x square, this is x square sin nx by n, and if you put n is equal to pi, you can see the sin n pi will be 0. Okay, because sin all pi is equal to 0, so this function will be 0, obviously 0, and this is also will be 0, because both in pi, if you put x is equal to pi and x is equal to 0, then the function sin will always be 0. So this term and this term will be 0. So the only term that will left is this. So what will be this term? Let me tell you. So this will be just 2x. This minus and minus will be plus. So it will be just 2x into cos nx upon n square. And we have to put the limit from 0 to pi. So if you put pi, okay. So what it will be? So it will be just 2 pi, and this will be cos n pi upon n square. But if you put 0, then it will be 0, because here x is present, so x will be 0, so it will be 0. So you will have 2 pi upon n square into cos n pi. What will be the value of cos n pi? Okay, so cos n pi will be just cos n pi will be just minus 1 whole to the power n. Okay, minus 1 whole to the power n. So this is the only integration value. Okay, and we have here 2 also. So what this will be? So this will be just equal to 2 by pi into what we have? We have 2 pi upon n square. So it will be just the value of this integration. Let me put, okay, the value of this integration. So this is 2 by pi, and here is, you can see here 2 pi by n square. So 2 pi by n square into minus 1 whole to the power n. Okay, and then what you have? Just pi will be cancelled out. So what will be the value? So an will be just 4 upon n square. Okay, 4 upon n square. 4 upon n square into minus 1 whole to the power n. So this is an. So a0 will be 2 by 3 pi square, 2 by 3 pi square, and an will be 4 by n square into minus 1 whole to the power n. Now we have to find out bn also. What is bn? So let me find out bn also. Okay, so what is bn? So bn can be written like this again, that 1 upon pi integration minus pi to pi f of x sin nx dx. So here f of x is x square. So x square into sin nx dx. Okay, now you can see this is even function and this is odd function, and odd into even is odd function. So odd function will be always 0 with this limit minus pi to plus pi. So this will be 0. So bn will be 0. So what will be the series? The series we have that f of x is equal to nothing but a0 upon 2 plus summation b1 will be 0. So the only term that will present here is a. So n cos nx. Okay, and n is equal to 1 to infinity. So we have a0 we have 2 by 3 pi square. So a0 half into 2 by 3 pi square. Okay, plus what is an? So an is, we have 4 upon n square. So this will be 4 upon n square into minus 1 whole to the power n into cos nx. So cos nx, and the summation will be from n is equal to 1 to 2. So we have f of x as pi square upon 3. Okay, plus sum over n is equal to, this is the series actually, n is equal to 1 to infinity 4 upon n square minus 1 whole to the power n cos nx. So this is the series f of x, and we can expand term by term by using n is equal to 1, 2, 3, 4, so on. Okay, so you can easily find out the series of f of x. And now one thing that we have to ask here also, we are asked here, so what will be the value of 1 upon n square, summation 1 upon n square. So okay, so summation 1 upon n square, to find out this, let me put x is equal to pi. Okay, both side. So if you put x is equal to pi both side, put x is equal to pi both side, so what will happen, this f of x is nothing but x square. So here left side will be pi square, and this pi square will be just here pi square upon 3 plus, so if you put x here also, a pi here also, so it will be cos n pi. Okay, cos n pi, so it will be again minus 1 whole to the power n. Cos n pi is again minus 1 whole to the power n. So minus 1 whole to the power n and minus 1 whole to the power, minus 1 whole to the power 2n. So it will be just 4 and summation n is equal to 1 to infinity minus 1 whole to the power 2n divided by n square. Okay, now let me put again. Okay, this side, let me put in this side. So what we have pi square is equal to pi square by 3. We have pi square is equal to pi square by 3 plus 4 summation n is equal to 1 to infinity minus 1 whole to the power 2n divided by n square. So we need this series actually, summation 1 by n square. Okay, because this is minus 1 whole to the power 2n. So if you put n is equal to 1, 2, 3, 4, so it will always be even term. And even term, if you get even term, so it will be always plus. It will be always plus. So we can write this just as 1, because minus 1 whole to the power 2n is always 1. Because this is even term. If this is odd term, then it will be minus 1. But here there is no option of getting odd terms because it is 2n. So this will be plus. So this will be just summation 1 upon n square. So we can write it like this also, pi square minus pi square by 3, and we can take this 4 in this side, so it will be 1 upon 4, and that will be nothing but 1 of summation n is equal to 1 to infinity and 1 upon n. So you will get this pi square, 3 pi square minus 2 pi square by 3, so it will be 1 upon 4 into 2 pi square by 3 equal to summation n is equal to 1 to infinity 1 upon n square. So this will cancel out, 2 and 2, so it will be pi square by 6. So we have pi square by 6 is equal to summation n is equal to 1 to infinity 1 upon n square. So that is what you have to put. Okay, so this is how you can solve these kinds of problems. The calculation will be a little lengthy obviously, because you have to integrate by parts each and every time. Okay, now let me solve another problem. So this is the problem now. Okay, and the Fourier series of the function f of x given as f of x is equal to minus k if minus pi less than x less than 0, and k if 0 less than x less than pi, and here the period is obviously in 2 pi. So it's minus pi to 0 and 0 to pi, so it will be actually minus pi to plus pi. Okay, and from minus pi to 0 it is minus k, and from 0 to pi it will be k. Okay, so let me again find out first the Fourier coefficients, that is a0, an and bn. Okay, so what is a0? We have a0 is equal to 1 upon pi integration minus pi to pi f of x dx. Okay, now we have to break this limit from minus pi to 0 and 0 to pi. So what you will get? You will get just 1 upon pi. So the first interval is minus pi to 0. So it will be minus pi to 0, and you will get minus k here into dx. Okay, plus we have 0 to pi, and then it will be k dx. K dx. Okay, k dx. So this, now what will be a0? So a0 will be just 1 upon pi into, so we have this is minus k into dx just, so minus k into dx, and if your dx integration of dx is x, and upper limit is 0, lower limit is minus pi, so 0 minus 0 minus or minus pi, it will be 0 plus pi, 0 plus pi. Okay, plus k into pi minus 0. pi minus 0. So what you will get? You will get 0, I think. 1 upon pi, then minus pi k plus pi plus pi. Okay, so you should get 0. Yes, a0 is equal to 0. So you will get a0 is equal to 0 here. Okay, now what is an? Now let me find out what is an. So an is equal to again 1 upon pi integration minus pi to pi f of x cos nx dx. Okay, cos nx dx. So it will be just 1 upon pi again integration minus pi to 0 f of x is just minus k. So it will be minus k into cos nx dx plus integration pi to 0 to k to cos nx dx. Cos nx dx. Okay, so what you will get now? I think again you will get 0 because this integration of cos will be sine, and here also integration of cos will be sine, and sine pi, sine all pi will be 0. So you will get again 0 here. Okay, and the finally you have to find out bn. So bn is equal to what? 1 upon pi integration minus pi to pi f of x sin nx dx. Sin nx dx. Okay, sin nx dx. Now what you will get? You will get here also that 1 upon pi into integration minus pi to 0 and f of x is minus k. You will get minus k sin nx dx plus integration 0 to pi k into sin nx dx. Okay, so you will get 1 upon pi. So this is now sin nx. So integration of sin nx is cos nx by n. So you will get minus k into cos nx upon n, and integration of sin x is minus cos x. Okay, this minus will be cancelled out. So cos nx by, and integration is into this integration is pi to 0. Okay, plus we have k into integration of sin nx is again minus cos nx. So it will be minus cos nx by n and limit 0 to this. So now let me find out this cos nx. So integration limit of, first we have to put 0. So cos 0 will be 1. Okay, so it will be 1, and you can common k by n also. So let me take common a by n. If you take common k by n, then what you will get? Just first term will be cos nx by n, and here is minus cos nx by n. So first limit put x equal to 0. Let me put here just 1 upon pi k by n. Cos 0 is 1. So 1, and cos n pi is minus 1 whole to the power n. Cos n pi, so it will be just 1 minus minus 1 whole to the power n. This kind of plus again we can write this 1 by pi minus, take this minus n. So minus 1 by pi into k by n. Again cos n pi is minus 1 whole to the power n minus 1 whole to the power n. Here is minus 1. So if you take common, and if you take here as plus sign, then it will be just minus 1 whole to the power n plus 1. Okay, so you can take common 1 minus minus 1 whole to the power n. You can take common here. You can see right in this way. You can write here in this way. Just you take common 1 minus 1 whole to the power n. Okay, then what you will have? You will have pi k upon n here plus pi k upon n here. That means we have just 2 pi k upon n into 1 minus 1 whole to the power n. And this is the result. 2k upon n pi. What is the mistake? The answer is here 2k upon n pi. Pi is in denominator here. It should k upon n pi. K upon n pi. So pi is here. It will be k upon n pi. K upon n. So it will be 2k upon n pi. 2k upon n pi. To 1 minus 1 whole. Okay. So this is your bn. This is your bn. So a0 and an is 0 and bn is this. So let me write. So a0 is equal to 0 we have. Okay. An is equal to 0 we have. And bn is equal to what? 2k upon n pi. 2k upon n pi into 1 minus 1 whole to the power n. Okay. So what will be the series? What will be the series? And you can see 1 minus 1, if it is 1 minus 1, then it will be 0. So when n will be odd, then it will be minus 1. But when n is equal to even, it will be plus 1. So for n is equal to even, you can see again here. For n is equal to even, this bn will be 0. This bn will be just 2k upon n pi into 1 minus 1. So it will be 0. So bn will only survive when n is equal to odd. And you can see when n is equal to odd, then this term will be just minus 1 and this minus will be plus. So it will be 2 just. So when n is equal to odd, you will get 2k upon n pi into 1 plus 1. So it will be 4k upon n pi. 4k upon n pi. Bn is equal to. Okay. So what will be your series? So your series will only for n is equal to odd, and you will get f of x is equal to just summation n is equal to 1 to infinity bn sin nx, because a0 and an are 0. And now here you have to put bn as n is equal to 1 to infinity, but this n should be odd. Okay, let me write first. So it will be just 4k upon n pi into sin nx. Now if you open the series, then you will get just f of x is equal to, first you can put n is equal to 1. So if you put n is equal to 1, then you will get this 4k upon pi into sin x. Then you will get n is equal to 3. So you will have 4k upon 3 pi sin 3x. Then you will get n is equal to 5. That means 4k upon 5 pi into sin 5x. So the series will be like this, something like. Okay, so you can take common as 4k upon pi. So if you take common 4k upon pi, then what you will get? You will get just sin x, and you can write the pattern sin x upon 1, plus you can see sin 3x upon 3, plus sin 5x upon 5, sin 5x upon 5. You will get this kind of series. Okay, so this is the Fourier series. Now what you have to find out? You have to find out minus 1 whole to the power n, 2n plus 1 is equal to pi upon 4. Okay, so now what you have to do? You have to just put x is equal to pi by 2 both sides. Okay, x is equal to pi by 2 both sides, because you can see here this is the sin nx. Okay, this is the sin nx, and if you put x is equal to pi or 0, then it will be vanish. And let me see what you have to prove here. So you have to put this. Okay, so you need minus 1 whole to the power n term. So what you have the series that we have already. Okay, should not be like this. Yes, so what we have just bn is equal to, we have bn is equal to, let's see this series. We have f of x is equal to just summation en and sin nx, and this is n is equal to 1 to infinity. The series is, open the series like this, it will be 4k upon pi by n, just sin x by x plus sin x by x plus sin 3x by x 3 1 plus 5x by 5 plus dot dot. This is, now if we put both sides, if x is equal to pi by 2, if you put x is equal to pi by 2, then what we will get? At x is equal to pi by 2, you can see this is in this range, x is equal to pi by 2 is in this range. So you will get k here, f of x is equal to, okay, and it will be just 4k upon pi into what you will get, sin pi by 2, sin pi by 2 plus 1 upon 3 into sin 3 pi by 2, okay, plus 1 upon 5 into sin 5 pi by 2. This kind of situation you will get 5 pi by 2 plus dot dot. Now what how you can write this, okay, so this can be written easily. You can see that 4k upon pi into what will be this series. So, and this kk, you can, if you want, you can cancel out. So let me mention later on. K is equal to 4k upon pi. And how you can manage this series? This can be written at sin n pi by 2. You can see this is nothing but 1. This is nothing but 1. This is 1 by 1. This is 1 by 3, 1 by 5. So this 1 by 1, 1 by 3, and 1 by 5 can be written as 1 by 2n plus 1. So it can be written as, you can see, 1 upon 2n plus 1, and the limit will be n is equal to 0 to infinity. So if you first put n is equal to 0, it will be 1. If n is equal to 1, then you will get 1 by 3. Okay. For n is equal to 0, 1, for n is equal to 1, 2 plus 1, 3. And if you put n equal to 2, then you will get 1 by 5. If n equal to 3, it will be 1 by 7. So you will get this 1, 1 by 3, 1 by 5. And now how you can get this? So this is nothing but, you can see here that this is all the terms that here, this is sin n pi by 2 actually. This is sin n pi by 2. But here n is odd always. Because if n is even, then it will be 0. You can see. If you have sin 2 pi or sin 4 pi, sin 6 pi, then it will be sin pi. If you put here 2 pi, then it will be pi. If you 3 pi, if you 4 pi, then it will be 2 pi, so it will be 0. So you have just pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. That means you will get plus 1 and minus 1 only. If you put here odd value, then you will get plus 1 and minus 1. Plus 1 and minus 1. And how you can get? So it will be just, you can see, minus 1 whole to the power n. So if you have minus 1 whole to the power n, then you can get for each and every value of n plus 1 and minus 1. If you put n is equal to 0 first, you will get plus 1. If you put n is equal to 1, you will get minus 1. Again, if you put n is equal to 2, you will get plus 1 again. So this value, sin pi by 2, sin 3 pi by 2, sin 5 pi by 2. So this will give you plus 1 minus 1, plus 1 minus 1. And minus 1 whole to the power n will also give you minus 1 plus 1 minus 1 plus 1. That means sin n pi by 2 is equal to minus 1 whole to the power n. But here when you write sin n pi by 2, please keep in mind, then n is odd value, only odd value, but otherwise it will be 0. But if you put minus 1 whole to the power n, so let me put here, if you write it this way also, then you can understand. If it will, let me put it sin m pi by 2, m pi by 2. So this m will permit only odd value. But this sin, here m is odd value, this sin m pi by 2, let me write here, this sin m pi by 2 is equal to minus 1 whole to the power n. But here m is equal to odd, but n or all odd and even, odd and even both, odd and even both. I think now you are understanding. Okay, so sin m pi by 2 is equal to minus 1 whole to the power n only when m is odd, but n is odd and even both. Because left side you will get only if m is odd, you will get pi by 2, 3 pi by 2, 5 pi by 2, which will give you plus 1 minus 1 plus 1 minus 1. But minus 1 whole to the power n will give you plus 1 minus 1 plus 1 minus 1 for odd and even both the values. Okay, so you can write this term as minus 1 whole to the power n. So what you will get here, this k and k will be cancelled out, and you will get this series. This series is equal to just pi by 4. Just you will get this series, that is n is equal to 0 to infinity minus 1 whole to the power n divided by 2n plus 1 is equal to pi by 4. Okay, and how you have to choose the point? What I have chosen here, x is equal to pi by 2. This is by experience. This is only possible by experience, because you have to predict that which value you have to put left side and right side, and you have to predict the value from this expression series. You have to think how you can construct this series from this Fourier expansion. Okay, so this is how you can solve problems from the very basic concept of Fourier series, from the very basic definition of Fourier series, and finding out the coefficient. And in the next class I will discuss some more thing about Fourier series, like odd and even function, half range series, okay, and complex form of Fourier series, partial identity, etc. So a lot of things are there. Okay, so for today, thank you.